let's base our problem the formula of 1/2 times r squared and theta. So let's substitute each part. First is 1/2 times 9/2 squared and times 7 pi over 6. And the result of this is, first you must get the you must solve the 9/2 squared first. So we will come up to the answer of 81/4, and let's multiply it to 1/2 and it becomes 81/8. And next will be 81/8 times 7 pi over 6, and which solves to the answer of 567 pi over 48. And in this part, let's find the LCD, which is 3. And it results in the final answer of 189 pi over 16 centimeters squared. So find the area of a circle with central angle of 108 degrees. The radius of the circle is 15 centimeters. So first, we must convert the 108 degrees to radians. So 108 degrees times pi over 180 results to 108 pi over 180. And if we simplify this, it results to this. 3 pi over 5 times the radius of the circle, 15 squared, and multiply it to 1/2, and which we can find and result to 3 pi over 5 times 225, and multiply it to 1/2, and 225 over 2, which we can find in this. Then 225 over 2 times 3 pi over 5, and let's gonna find the, and we must find LCD, which is 5 is for 1 and 225 45. So 45 times 3 is 125 pi, and 2 multiplied to 1 is 2. So 135 pi over 2 centimeters squared is our answer.
If cosecant theta is equal to 2 and cosine theta is less than 0, find secant theta. So, since duha naman the quadrant ang pwede mag-contain of positive numbers, but given nga ang cosine theta must be less than 0, so ang atong gamiton sa hypotenuse is negative square root of 3. So, na siya sa quadrant 2. Dayon, ang cosine is hypotenuse over, adjacent over hypotenuse. So, negative square root of 3 over 2 is less than 0. Sakto siya. Next is secant. Find secant. So, ang secant is hypotenuse over adjacent. So, since ang atong denominator is square root, so need natin siyang
Rationalize.
Rationalize. So, ato siyang multiply sa number which mahimo siya siya. So, square root of 3. So, kani siya. So, square root of 3 over square root of negative 2 times square root of 3 is negative 2 square root of 3. Then, square root of 3 times square root of 3 is square root of 9. So, also equals to 3. So, atong secant is negative 2 square root of 3 over 3. What of the other trigonometric functions of theta is what tangent theta is equals to negative 4 over 3, and sine theta is less than 0. So, since ang cotangent is adjacent over opposite, so adjacent opposite. So, pag find mo sa C is, ano siya, katong, ano siya. So, a squared plus b squared, square root, so 25, square root 25 is equal to 5. So, mo na ang minus. So first, sine, opposite over hypotenuse. So, ang opposite is negative 3 over hypotenuse 5. So, ang next is cosine, adjacent over hypotenuse. So, adjacent is 4 and hypotenuse is 5. Tangent is opposite over adjacent. So, negative 3 over 4. Ang cosecant is mo na siya ang balisa sine. Sine ba? Oh, sine. So, mo na siya. So, more na siya. Gawin mo na siya. Oh, 1
Over sine.
1 over 6. Negative 3, 5. So, magbalik na siya. 1, 5, and 3. So, ang second diode is balisa cosine. So, ano siya, parang siya po sa gibuhat ganiha. So, reciprocal ni mo. So, ano siya, 5 over 4.
First is find the period of the function in the given negative 2 cos 1/4 times x minus pi over 2. So, atong first step is, diretso na i-distribute ang 1/4 sa x o sa negative pi over 2. So, ang mahitaba na is 1/4 times x minus pi over 8. So, atong i-mind ang standard equation sa period, which is a cos times bx plus c plus d, where a cos is the amplitude, bx is the period of the function, c is the shift of the graph, either left or right, and d is the shape of the graph, either upward or downward. So, and we mind the standard equation for getting the period, which is the regular period over absolute value of b, and the regular period is always 2 pi. Then we will substitute 1/4 since this is b based on the equation. So 2 pi over 1/4, 2 pi. Then since this is a complex fraction, we will we'll do the reciprocal. Then 2 pi times 4 over 1 is 8 pi. The next question is find the absolute value of a plus b, where in the equation y equals 4 minus a over 2 cos times bx over 3 minus pi, where the amplitude is 3 and the period is equal to 4 pi. So first step is to find the a. In finding the a, we will use this one. Then 4 minus a over 2 equals 3. Then we will do the addition property of equality. We'll do it here. So the answer would be negative 1. Then we will times it to negative 2 so that we can cancel the denominator here. Times on both sides, so a is equals to 2. Then in getting the b, we will use the regular period over absolute value of b. So 2 pi over b over 3 since it's given here. And then we will times it in both sides, 1 over 2 pi to cancel 2 pi, 2 pi, 2 pi. Then the answer will be 1 over b over 3 equals to 2. Then since this is a complex fraction, we'll do it again. 1 times 3 over b equals 2. Then the answer will be 3 over b equals 2. Then we will times it with b so that ma-cancel. Then 3 is equal to 2b. Then divide both sides to 2. b is equal to 3 halves. Then the question was absolute value of a plus b. So the a is 2, then the b is 3 halves. So equals to 7 over 2.
Cosecant a plus 1 over cosecant a minus 1 equals to 1 plus sine a over 1 minus sine a. So here are the steps. Step 1 is to manipulate the left side, which is cosecant a plus 1 over cosecant a minus 1, which would equate to 1 plus sine a over negative 1 plus 1 over sine a, to sine a plus 1 over negative sine a plus 1. This next step is to simplify this one. 1 plus 1 over sine a over negative 1 sine A to sine A plus 1 over negative sine A plus 1. The next is to join them. Which will equate to negative 1 plus sine over A. Next is to convert the element fraction 1. So 1 is equal to 1 over 1. So here, negative 1 over 1 plus 1 over sine A. The next step is to find the LCD for negative 1 over 1 plus 1 over sine A is to sine A. So since there is shown that the LCD is sine A, next is adjust fractions based on the LCD, which would equate to sine A over sine A plus 1 over sine A. Since the denominators are equal, we combine the fractions into this. Sine over A plus 1 over sine A equals to sine A plus 1 over sine A over negative sine A plus 1 over sine A. Next step is to divide the fractions. Sine A plus 1, quantity of sine A plus 1 times sine A, then sine A quantity of sine A plus 1. Then next is we cancel the common factor, which is sine A. So here's the answer, sine A plus 1 over negative sine A plus 1. And we concluded that we showed that the two sides could take the same form, so the answer is 1 plus sine A over 1 over sine A, which is true.
So prove that 1 plus sine A over 1 minus sine A minus 1 minus sine A over 1 plus sine A is equal to 4 tangent A secant A, and that we should find it to be true. Okay. So first, what we do is to simplify this whole equation. So what we do is we find the LCD. So the LCD is 1 minus sine A and times 1 plus sine A. That's the LCD. Now, we combine these terms. So we have 1 plus sine A times 1 plus sine A minus 1 minus sine A times 1 minus sine A. So here is an expanded version, or a bit simplified na. So here we have 1 squared plus 2 sine A plus sine squared A minus 1 squared minus 2 sine A plus sine squared A. So over 1 minus sine A times 1 plus sine A. So we distribute our negative value to the terms inside the parentheses. So here we have 1 squared plus 2 sine A plus sine squared A minus 1 squared plus 2 sine A minus sine squared A, which is equal to, so here we just combine the like terms. So 0, 0, 2 sine A plus 2 sine A, so that's 4 sine A, and sine squared A minus sine squared A is 0. So all we have left is 4 sine A over 1 minus sine A times 1 plus sine A. So if we simplify the LCD, we actually get 1 squared minus sine squared A, which is equal to 1 minus sine squared A, which is then equal to cosine squared A, which is its trigonometric identity. So here 4 sine A over cosine squared A is equal to here. So we just expand it a bit further. So we have 4 times sine A over cosine A times 1 over cosine A. So just copy it. 4 times, since this one, its identity is just equal to tangent A, and this one is the reciprocated form of secant A. So we have 4 times tangent A times secant A. So there, and it is true. Yes!
So hello, this is the problem. Let A and B be acute angles such that cotangent A is equal to 7 and secant B is equal to square root of 10. Find the cosine of A plus B. So first, to find the cosine of A plus B, we have to derive this, we have to follow this formula. Cosine A plus B is equal to cosine A times cosine B minus sine A times sine B. So through a lot of process and derivation of the given, we have come up with these values, which is cosine 7 square root of 2 over 10 times 3 square root of 2 over 10 is equals to 7 times 3 times square root of 2 squared is equals to 100, which can be which can be simplified into further is 7 times 3 times 2 equals 100, and 42 divided by 2 is equals to 21 over 50. While sine 2 square root of 2 over 10 times square root of 10 over 10 is equals to square root of 20 over 100, and cancel 2, and square root of 5 over 100 cancel will be equals to square root of 5 over 50. So after this, the answer of this problem will be 21 minus square root of 5 over 50.
Given sine alpha is equal to negative 8 over 17 and sine beta is negative 1 over 2. Find cosine A plus B if both A and B are in quadrant form. So to illustrate the given, I've made this illustration. So the opposite is negative 8, so this is negative 8 here. And then the hypotenuse is 17. And to find the adjacent, I use the Pythagorean theorem, which is a squared plus b squared plus c squared. So I substituted negative 8 and 17. I acquired them, and using this process, I acquired b is equal to 15. So my adjacent is 15. Thus, my cosine is 15 over 17. And then for the second angle, we also use the Pythagorean theorem, a squared plus b squared equals c squared. And then, using the given, I substituted negative 1 for a and 2 for c squared. And then, using this process, I got b is equal to square root of 3. And since I know that my adjacent is square root of 3, then I already know what is my cosine. So my cosine is square root of 3 over 2. And then, to solve this cosine A plus B, we need to use the cosine sum identity, which is cosine A multiplied by cosine B minus sine A multiplied by sine B. So I first solved the product of my cosine. So 15 over 17 multiplied by square root of 3 over 2. And I got 15 square root of 3 over 4. And then for my side, I multiplied negative 8 over 17 to negative 1 half. I acquired 8 over 34. And I subtracted both products, and I got 15 square root of 3 minus 8 over square root of 4. And this is my final answer. 15 square root of 3 minus 8 is equal to 34.